Assuming we have such a question, show how the following records can be put in a random file that is supposed to keep 100 records. The file is supposed to keep a maximum of 100 records, and we have these IDs, or these records. So this is the first record, record 1. This is the second record. This is the third record, and this is the fourth record. They're supposed to be kept in a random file. Now here, I told you that in order to know the position where to put those values in a random file, we use a formula called the hash algorithm. Now, there are so many formulas. Hash algorithm is very simple. It's just a formula you apply to the key value. Now, this is our key value in this case. The primary key values are the key values. So you apply a formula there, then the answer that you get from the formula, that answer gives us the position. That's what it means. So there are very many formulas you can use. As long as for you can apply the student I to the key value, primary key value, and it gives you an answer. If it gives you the answer, that's the position. So you as a programmer, it's up to you to decide. But then the common method they use is the one of modulus. You get? And that's the common one they use even in your exam, but you never really can bring another question. So this is going to be our file. This file is supposed to keep 100 records. It's supposed to keep 100 records. So we have record 1, we have 2, we have 3, we have 4, we have 5, we have 6, up to what? Up to 100. We have 7, we have 8, we have 9, until what? Until position what? 100. Hope you understand, because I cannot draw 100 boxes. Until what? 100. This is our file. This is our random file. So the first record we want to put is this one of Anne, having the student ID of 102 and the class year 11. So in order to know which position where to put Anne, we shall perform a hash algorithm. We shall apply a formula to that, to the student ID value of, or the key value of Anne. The key value is the student ID value, which is 102. In this case, for me, I'm going to choose the hash algorithm as, so I'm going to use my hash algorithm as key value modulus file size gives us the position where to put the value. This one gives us the position. Key value modulus, the file size, should give me the position. Remember now, position can be referred to as index. Also, if you want, give me the position. So for Anne, I'll get 102 modulus 100, because our file size is 100. So 102 divided by 100, what is the modular? What is the remainder? That gives us 2 as the remainder. That's what we get. Good. So which means now Annie's position should be in position 2. Annie's record. Now I need to see what I mean by record. What I mean by record is all these details about Anne must be in that what position. So here we shall put Annie's record here. We shall put Anne year 11. Then we put the student ID as what? 102. That's what I mean by Annie's record. Then move on next to Alex's record. Now, following the same formula here, we shall get the key value of Alex, which is 105, modulus 100, and that will give us 5. Which means now we shall put Alex's record in position 5. So the computer will come here and put Alex's record here. Alex is in year 12, and the student ID is 5. You see, the whole record goes in that position. Then to know which position where to put Danny's record, it will get Danny's key value, modulus 100, and that will give us 8. So which means we'll put now Dan's record in position 8. So here we shall have Dan, here 13, then we shall have 108. That's why we shall put Dan's record. Then next we have Mary. Not know where to put Mary's record to get the student ID of Mary, which is the key value, modulus 100 divided by 100. The remainder is what? Is 5. The remainder is, oh, sorry. I think I made a mistake. Alex was supposed to be in position 5. Sorry. Alex was supposed to be in position 5. I made a mistake. Alex was supposed to be in position 5, not position 2. Sorry. Alex's record was supposed to be in position 5, which is this. So yeah, supposed to be Alex, year 12, and the key value is 105. So here, you find that Mary's record is supposed to be in position 5, but position 5 is already taken up. The computer can't keep Mary's record and Alex's records together. It can't mix them up. So now here, since the computer has calculated the position where it wants to put the value in the random file, but the position is already occupied, that is called clashing. That position is called what? Clashing. It's called what? Clashing. Clashing is the process where the computer calculates a position where to put a value in a random file, but that position is already what? Occupied. It's called clashing, and some sources call it what? Collisions in a random file. Can be called what? Collisions also. So what does the computer do in this case? It cannot leave out Mary's record because Alex is already in position 5. No. So there it applies many methods to solve that. But then the common ones that are in your syllabus are what we call one, close what? Searching and open. What do I mean by that? It will begin searching for any free position to find any free position where it can put that record. So it will continue searching. In case it finds a free position, it will put the value there. For example, here, if it searches here, 6 is free. So it can put Mary's record where? Here. Since position 6 is free. So it will put Mary's record year 8, then 2005. You see, it has solved the situation of clashing. That is one method how it does it. Now, that is called the process of checking the file for any free position where to put the value. Is called open hashing. That is called open what? Hashing. Open hashing. It is searching for any free position where to put the value. That's called open what? Hashing. The second method it could use will be if it finds that there's no, for example, let's assume that all positions are taken up. All positions are taken up and Mary cannot fit anywhere. So what it can do in that case can also apply another method where it can get Mary's record and copy it in an extra memory space. So what the computer will do, if it realizes that all these positions are occupied, they're taken up, and there's nowhere to put Mary. In that case, what it will do, it can create an extra file which is empty. So here, assuming all these positions are taken up, they're occupied, and Mary has no position. So what the computer will do, it can go and create an extra free memory space, what we call an extra bucket, something like this, and say, okay, you know what? Let's put you there in the extra memory space. This memory space can be referred to as an overflow area. An overflow area, which means that overflow comes from space is full and the extra values that want to come. You get? So here, it will go and put Mary's record here. So it puts Mary, year 8, then it even puts the ID of Mary, which is 2005. So now it has put that record in what we call the overflow. This is called an overflow area. Some books might call it an empty bucket, overflow bucket, anything. But for you, logically, what I mean here is it creates an extra memory where it puts all values that want to join, but the memory is already what? The memory of the computer is already full. You get? It's called an overflow area. So that's why it will put the record. So now that process is called closed clashing. Closed clashing. So closed clashing is where the computer can put a new record into a separate memory space or a separate file. You get? It's separate from the random file. You can put the record there and keep it there. Then open hashing. So it's called closed hashing. Closed hashing. It's called closed hashing. Closed, not clashing, but closed hashing. Hashing comes from put the value in a random file. That's called closed what? Hashing. Then this one is called open hashing, whereby it has to search for any empty position in the file, beginning from the next position or the position which is coming after what the record was supposed to be. Then to continue searching. If it finds an empty position, it puts the record there. That's called open what? Hashing. So that's how random files work. And we are going to stop here for today. I'm going to send the videos on file processing so that you can make your own notes. Okay. Thank you. You can end here for today.